Section 3.5 is symbolic arguments. So, in this section, what we're going to do is take a person's argument, construct it into symbols only, and then analyze the symbols to see if they're actually making a logical argument or not. A symbolic argument consists of a set of premises and a conclusion. It's going to be called a symbolic argument because we generally write it in symbolic form to determine if it's valid or not. An argument that's valid will have its conclusion necessarily follow from a given set of premises. You're going to be able to tell if an argument's valid when you do a truth table because it will be a tautology, which remember is a column of all truths. An argument is invalid or called a fallacy when the conclusion does not necessarily follow from the given set of premises. When you look at the truth table, you will be able to tell it's invalid because at least one item will be false in the solution column of the truth table. A common form that you'll deal with often is called the law of detachment. It's also called modus ponens. I don't ever use that terminology, but if you want to know it, that's fine. So the law of detachment will look like this. The first premise will be an if-then statement. If P, then Q. The second premise will be P. The conclusion will use this symbol. The 3 dots is read as therefore Q. So an example could be, if you are rich, then you have money. You are rich, therefore you have money. Now, when you go to prove this statement as being a valid argument, what you do is you take the first premise with a conjunction with the second premise. So remember, our first premise was if P, then Q. We'll do a conjunction, and then our second premise was just P. Notice it's in brackets because you want to figure out the truth value of just that conjunction. Then you put the conditional statement in there. So if all of the premises happen, then the conclusion should happen. It's this truth value that you're looking for. If you get all T's in that truth column, then you have shown that it is a valid statement. The law of detachment has already been proven. It's proven in your textbook on page 137. So when you go to prove whether an argument is valid, it has a 5-step procedure. First thing you want to do is put it in symbolic form. Now, there are going to be some forms that are already known to be valid. For example, the law of detachment. So compare your symbolic argument with the ones that are already known to be valid or invalid. If you are in one of those forms, you do not have to make a truth table. You can just say, this looks like law of detachment, therefore it is valid. If the argument is not on the list of commonly valid or commonly invalid arguments, then you're going to have to do a truth table. So first thing you want to do is you want to do a conjunction of premise 1 and premise 2, and then you'll do a conditional statement. So you'll have premise 1 and premise 2 implies the conclusion. Once you have it in that form, you will construct a truth table for that statement. If the answer column of the truth table has all truths, that means it's a tautology and the argument is valid. Just as a reminder, whenever you have a conditional statement that's a tautology, it is also called an implication. Okay, so let's look at an example. Determine whether the following argument is valid or invalid. If you have enough reward points, then you get a free flight. You do not get a free flight, therefore you do not have enough reward points. Okay, so the first thing we're going to do is we're going to construct this in our statement. So we need to get it into symbolic form. So I'm going to move it up so we have enough room. Okay, so first we have this statement. If you have enough reward points, then you get a free flight. So that would be premise 1. And it's an if-then statement, so that's a conditional. So if you have enough reward points, we'll call that P. Then you get a free flight. We'll call that Q. So that's your first premise. Now your second premise is you do not get a free flight. So that is premise 2. So remember, your flight was Q, and we are not going to get the free flight, so we need to negate Q. Now we need our conclusion. Therefore, you do not have enough reward points. So therefore, negation of P. Okay, so we want to show that this is either valid or invalid. So when we do that, we need to take premise 1 and premise 2 as a group. And so if all of this is true, then the conclusion should be true. Okay, so that's what we need to create our truth table for. So I'm going to scoot this over a little bit so that we can build our truth table for it. So we only have 2 statements. We have statement P. We have statement Q. We are also going to need a if P then Q. We are going to need a not Q. We are going to need a if P then Q and not Q. And then we are going to do a not P. And then last we'll pull it all together. If P then Q and not Q implies not P. So I have the traditional form of a truth table, which is very long, but it'll be the last column that you'll want to look at. And if that column is all truths, then that means the statement is true. So first, let's do our initial columns. So for 2 statements, the P will be 2 truths and 2 false. The Q will be every other, true, false, true, false. Okay, then I think like the negation columns are the easiest ones, so I'm going to do that first. The negation of Q would be false, true, false, true. And the negation of P would be false, false, true, true. Okay, then let's do our if P then Q column. Okay, so remember the only time if P then Q is false is in the situation where you have a true first and a false second. Otherwise, you get a true. Okay, then we need to take the if P then Q and do a conjunction with the not Q. So we need to look at if P then Q, we need to look at the not Q, and we need to do a conjunction. So remember, the only time you get a true here is when they are both true. Otherwise, you will get a false. Okay? And then last, we need to take the if P then Q and not Q column that we just found, and we need to do an implication with the not P. So we need to do if false, then false. That's a true statement. If false, then false. If false, then true. If true, then true. Notice you got a column of truths. That means this was a valid argument. So, our original phrase was, if you have enough reward points, then you get a free flight. You don't get a free flight, therefore you don't have enough reward points. That's valid. So there's going to be 4 different standard forms of arguments that are going to be considered valid. And we actually just proved that one on the last statement, We just did on the first example, the law of contraposition. So notice we had this statement, If you have enough reward points, then you get a free flight. You did not get a free flight, therefore you did not have enough reward points. So when you put your argument in symbolic form, if you notice that it is of this form, you do not need to do a truth table. You can just stop and say, this is the law of contraposition. This is always a valid argument. Done. Also would be the law of detachment. So if P then Q, the second premise is P, therefore Q. So an example is, if you are rich, then you have lots of money. You are rich, therefore you have lots of money. That's called the law of detachment. If you ever notice your argument is in that form, just state the law of detachment is always valid. Do not do the truth table. The law of syllogism. If P, then Q. If Q, then R. Therefore, if P, then R. So an example of this is, if you are rich, then you have lots of money. If you have lots of money, then you have a big house. Therefore, if you are rich, then you have a big house. That's called the law of syllogism. The last one is called the disjunctive syllogism. So P or Q, not P, therefore Q. So an example of this was, I will have steak or chicken fajitas. I did not get steak fajitas, therefore I have chicken fajitas. So all four of these are called valid arguments. There are also two forms that are always invalid. The first is called the fallacy of the converse. So that form is, if P then Q, Q therefore P. So for example, if I am rich, then I have lots of money. I have lots of money, therefore I am rich. So what they're saying here is that this does not necessarily implicate this. So maybe you have lots of money on you, but maybe it's not yours. Maybe you're holding your boss's money. Okay, so if you're ever in this form, this is the fallacy of the converse. This is always invalid. So if you did a truth table, it would not be a tautology. The other one is the fallacy of the inverse. If P, then Q, not P, therefore not Q. So if I am rich, therefore then I have lots of money. I am not rich, therefore I don't have lots of money. This is also going to be considered an invalid statement. The not Q is not a logical conclusion of the not P. So, for example, let's look at a situation. We will put it in symbolic form first, and then we will look at our commonly valid and invalid forms and see if it fits any of those cases. So, if you are on Instagram, we'll call that P, then you see my pictures. Then Q. If you see my pictures, Q, then you know I have a dog. R. So those are our two premises. Therefore, if you are on Instagram, P, then you know I have a dog. R. Okay, so what we would do, once you have it translated, you would look at your commonly valid and commonly invalid arguments to see if it is of any of those forms. Okay, so you should notice that this looks like the law of syllogism. So as long as you can make that recognition, you do not need to do a truth table. You can just simply state that this forms the law of syllogism and that therefore this is a valid argument. Let's look at another one. Determine whether the following argument is valid or invalid. If it is snowing, we will call that P. Then we put salt on the driveway. Q. We put salt on the driveway. P. Therefore, it is snowing. Q. Okay, so you have it in symbolic form. So let's look at our commonly valid arguments and see if we can get this one in any of the common forms. And you should notice that this looks just like the law of detachment. You do not need to make a truth table. Simply say this is the law of detachment and that this is valid. Determine whether the following argument is valid or invalid. If it is snowing, then we put salt on the driveway. It is not snowing. Therefore, we do not put salt on the driveway. Okay, so let's see if this is any of our common valid forms. So it's definitely not law of detachment because of the negations. It is not law of syllogism because we only have one conditional. It is not the disjunctive because we never had the or statement. And it is not law of contraposition. We've got the first statement, but the second two are going out of order. So it's not law of contraposition. So right now it is not a standard valid argument. So let's check our standard invalid arguments and see if we fit any of those forms. So the standard invalid are the fallacy of the converse and the fallacy of the inverse. Okay, it is not the fallacy of the converse because the second two items are not negated. But it does fit the fallacy of the inverse. If P, then Q, not P, therefore not Q. The fallacy of the inverse is always invalid. You can do a truth table if you want to, or you could save yourself some time and just quote the fallacy of the inverse. Now, if the statement would not have fit any of those forms, you have no choice. You need to do a truth table. So let's look at one more example where we are forced into a truth table. We have no choice. Use a truth table to determine whether the following argument is valid or invalid. If my cell phone company is Verizon, then I can call you free of charge. I can call you free of charge, or I can send you a text. I can send you a text, or my cell phone company is Verizon. Therefore, my cell phone company is Verizon. Okay, so first, let's translate this. So I'm going to scoot this up a little bit so we have some room. Okay, so if my cell phone company is Verizon, then I can call you free of charge. So that's one premise. I can call you free of charge, or I can send you a text message. That's your second premise. I can send you a text message, or my cell phone company is Verizon. That's your third premise. And then your conclusion is my cell phone company is Verizon. Okay, so remember what you need to do is a conjunction of all three of those premises. And you need to show that this implies the conclusion. Okay, so the column that you're going to really care about is going to be this column right here. If that ends up being all T's, then you have a valid argument. If not, it's invalid. So I'll do the truth table the way the book does it. So first we need to come up with all of our options for P, which is going to be 4 trues and 4 falses. All of our options for Q, which is 2 trues, 2 falses, 2 trues, and 2 falses. We need all of our options for R, which is true, false, true, false. And we can just carry over our Q's. And our R's. Our Q's. And our P. Okay, now we need to figure out the truth value of each premise. Okay, so if P then Q, the only time this is false is when you have a true leading to a false. Otherwise, it's a true statement. Our second premise was Q or R. This is true when you have 2 trues, 1 true, but it is false if they're both false. Then we need our truth value of our last premise, which is R or Q. So as long as you have 1 true, it will be true. Okay. Then we need to take those 3 columns and we need to figure out the truth value of all 3 of them being true simultaneously. And I'm just going to put it in this column just for ease. So I will use this column for the truth value of the 3 premises all happening simultaneously. So we would do true, 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 true. Soon as you get 1 false, you're going to need a false statement. True, 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 false. Okay, so now I need to take the column I just found and the conclusion, and I need to do the conditional statement. So if the first column, then the second column. Okay, so if I have a true, then I have a true. That's true. If true, then true. True. If false, then true. If false, then true. If true, then false. Okay, that's the one time you have a bad situation in a conditional statement. So we are going to have a couple falses in here. And because you have some falses, this is no longer a tautology. So therefore, you would be able to say that this argument is invalid.